Simplifying algebraic expressions involving radicals. So we'll start with reviewing exponents. So 256 is 4 times 4 times 4 times 4. But we can group these, right? 4 times 4. What do you call 4 times 4? 4 squared. And 4 times 4 is? 4 squared. So we could think of this as 4 squared squared, right? We've got a power to a power. Power to a power, what do you do with the exponents? Multiply them. So we end up with 4 to the power of 4. Similarly, 729, okay, is 6 threes. You can split that into 2 groups. So we have 3 cubed times 3 cubed, which is 3. Now what goes in here, a 2 or a 3? 2, because we're squaring that, right? There's 2 of them. Okay, and don't be fooled by the pattern. Okay, so the idea here is we've got 3 cubed squared, which is 3 to the power of 6. I mean, we could just directly count that there were 6 of them, right? But we're trying to get the idea of, remember, simplifying radicals, squares, perfect squares. 81 is 3 times 3 times 3 times 3 times 3 is 3 squared times 3 squared, or 3 squared squared, and 3 to the power of 4. Okay, just this idea of looking for things that are squared, which then implies we're looking for things that have square roots, right? So squares have square roots. And it's all there. 64. What's this? 2 cubed. I don't know, ink or something. That's good. Okay. We'll just write a 3 in there and then a 3 in there. Wonderful. It's like yesterday, wasn't it? Guys, just pause while we. Didn't even pause. Oh, jeez. Okay, really? Like nothing's happening? Okay, so we've got 2 cubed, 2 cubed, right? What we want to do is split the group in half, right? Because if we take half of it, then we know we can write that as something squared, because we're multiplying 2 equal sized groups together. So, got a bit messy, right? So 2 cubed times 2 cubed is 2 cubed squared. The important idea here is this is something squared, right? It gives us 2 to the 6th. And then the next important idea is that this is what's being squared, that is 2 cubed that's being squared. Okay, 5, we've got a group size of 5 this time. Okay, so I can write it as something squared, so I can take 5 squared times 5 squared, right? Take the even. So I just say, well, I can split it into a group of 4 and a group of 1. The group of 4 will be a perfect square, right? Because we can take half of any even number. So we've got 5 squared squared times 5, or 5 to the 4th times 5 to the 1, right? So if we have an odd power, we're going to want to split one of them off, leaving us with an even and an odd, and the even power has a square root, right? That's that thing up there. You have the power. So 216, even power, we got 6 squared times 1. Okay. So the idea is whether it's an odd or an even power. If it's an even power, it's nice, right? We can just take half of the power. That will be our square root, right? Because it's half of that squared. You're looking at this line here all the time, right? All right. What if they aren't numbers? What if they're variables? So we have x. We have 10 x's. We can split that into 2 groups of 5, right? So it's x to the 5th times x to the 5th, which is x to the 5 squared. Okay, so really all you're doing is just the idea of taking half the power if it's even. Y to the 6th can be written as y cubed times y cubed, or y cubed squared. Again, you're taking half the power, that's the cubed, and squaring it. M to the 24th, half of 24 is 12. So it's m to the 12th squared, which will be m to the 24th, right? Did you get that all down? It's all going down. I guess I better go back and write. Go back. Go. Core i7, sure. Oh, okay, now it should like leap 5 pages back. I pitted a fool who's got to watch this video. Yeah, back to the beginning. Okay, so that's all in there.
Then it goes blank.
Okay, so 5, 5, 5. I can actually tell when that's going to happen. The line is really thin. 3 squared, 12, 12, 12 squared, which is 24. Okay, Z's. How many Z's do we have?
7.
We got 7 Z's. So we can take 6 of them and write them as Z cubed times Z cubed times Z. 3 plus 3 plus 1 is 7. So the idea is you take the odd number. You take 1 away from it. To get an even number and you divide that by 2, that's what you're splitting it. So it becomes Z cubed squared times Z, or Z to the 6 times Z. That's always just a 1. W to the 13. It's going to be W to the 6 times W. So 13, we take 1 away, we get 12. We divide that by 2. Right? Because I want to write it as the square of something because that has a square root. And that's the idea with this simplifying radicals. So we've got W to the 6 squared times W. Remember, that's a 1 all the time, which is W to the 12th times W to the 1. Okay, so key idea. If it's odd, 37, take 1 off it, 36, divide by 2. You can write that as P to the 18 squared, or P to the 36 times P to the 1. Okay, so key idea, right? If we have an odd power, we're going to take 1 away from it, gives us an even. So here we go, simplifying monomial radicals. Simplify each of the following using the process indicated. The root of 729. Okay, use your calculator. What's the square root of 729? 27. 27. But since 729 is 3 to the power of 6, it's 3 cubed squared, which is 3 cubed squared. So we can write 729 as the square root of 3 cubed squared. What do you do when you take the square root of something that's being squared? You just get the something, right? So the square root of 3 cubed squared is 3 cubed, which is 27. So, what if you do the square root of 325? What do you get? 3125. 55.9016. So 55.901. Dot dot dot. I'm just going to show that it keeps going. I'm not rounding. And I am sort of like I'm just writing out a few decimals and then giving you 3 dots. Say, hey, this keeps going. But 3125 is something, some power of 5 that's being squared times 5. So let's go back to here and go, what's 3125 divided by 5? 625. 625 is 25 squared. It's 5 squared squared. Now the root of 5 squared squared times the root of 5 is equal to, well, the square root of something that's being squared is just the something, 5 squared. times root 5. So it should be 25 root 5. Okay, and let's just go here and go 25 root 5. Right? Same number, 55.901. Okay? That's part B. We're doing part C, right? So we x to the 10th. Okay, so if it's just a variable, you're going to take half the power. Half the power of x to the 10th is x to the 5th. You write it as x to the 5th times x to the 5th. You're not actually even going to write these things, right? At some point, you're just going to get to the point where you're just going to say, hey, this is the more efficient way to do this. So here we're just showing the details, right? So again, what are we going to do here? W to the 13, that's an odd power. So I'm going to take away one of the w's. That means that I have to get w to the 12th. Can I write that as a square? Yeah, because half of 12 is 6. So it's 6, 6. That's 6 squared. So we have w. So the square root of w to the 6 squared is w to the 6th. Times the root of w, which is w to the 6th root w. Okay. It's actually easy to describe it, that, you know. Okay, let's do it the real way, right? So here's what we're going to do. So, I have x to the 8th. It's going to do that again, right? It's all going to disappear at some point. It's the square root of x to the 4th squared, right? So what is the square root of x to the 8th? At some point, it's all going to disappear. X to the 4th, right? What do you do? So it's right up here. See that? It says x to the 10th. There's a square root of x to the 10th there, right? Which is x to the 5th. You have the power, right? You take half of the power. So if it's an even, you know, just, there we go. That's going to stick. Thicker writing. So if it's even, just take half the power, right? X to the 4th. If it's odd, what do? We write it as the root of w to the 6th times the root of w. What's the square root of w to the 6th? Is w3, w cubed. Root w, right? We still have one root w left over. If I want to go from mixed radical to entire radical, then I have to square this and put it under a root sign, right? It gives me the w to the 6th. Times root w gives me the root of w to the 7th. Square root of y to the 12th is y to the 6th. Square root of 64x to the 9th. Okay, does 64 have a square root? What is it? 8. Okay, do you think we can just do this one line, not show a bunch of work? You want to try it? So what do you think it is? 8, then what? X 4, and then? Okay, good. Not good. Good you said that, right? So we can just. So let's split it. Actually, wait. Let's split it like this. So I want things that have square roots, right? 64 has a square root. Even powers of x have a square root, so we'll go with x to the 8th times x. Okay, so those first two terms, 64x to the 8th, that has a square root, right? Okay, so what's the square root of 64x to the 8th? 8. What's the square root of x to the 8th? X to the 4, right? Half the power. We still got that root x. Okay? Square root of 20w to the 10th. Okay, so what's the largest perfect square that goes into 20? 4. Does w to the 10 have a square root? Sure does. It's even. How do I get a 20? I've got a 4. What else do I need?
Where'd you get 4 from?
The largest perfect square that goes into 20. So what I'm going to do is I'm going to write 20w to the 10 as a product of things that have a square root and things that don't. Okay, and then I could split out the things that have a square root and the things that don't. And what's the square root of 4w to the 10? 2w to the 5th, root 5. Okay, so the idea here is we want to write it as the product of a perfect square, something that has a square root, and some other number, or power. So, root 27, what's the largest perfect square that goes into 27? 9. So 9. Does y to the 12th have a square root? Yes. And then, what do I need to get 27y to the 12th under here? I got 9y to the 12th. I need a 3. Okay, so we split that out. We say we've got 9y to the 12th, and I know that has a square root, and root 3, and I know that's just going to be written as root 3. What's the square root of 9y to the 12th? So 3y to the 6th, root 3. Let me drag that up a bit. Okay, 3x times the root of 75x to the 5th. So the 3x right now is just along for the ride, right? You're just going to write a 3x in front until you've got something you can multiply it by. Okay, so then you go 3x. What's the largest perfect square that goes into 75? 25. What's the largest perfect square that goes into x to the 5th? X to the 4th, right? We got to go down 1. We got to go to an even number. We can't go up 1. There's, Okay, 25 times what gives me 75? 3. So we got a 3, and how do I get x to the 5th? 3 and then an x, right? Okay. So what's the next step? We got 3x. The root of 25x to the 4th is the thing that has a square root, and the root of 3x, the thing that doesn't have a square root, right? Just has to be left under the radical sign. What's the square root of 25x to the 4th? 5x squared. Okay, now the 3x that's been hanging around now has something that it can multiply, so our final answer is 15 x cubed root 3x. Okay, any questions on that one? Right, kind of puts it all together, right? We've got the mixed radical with the number, the root 75. We got an expression in front that's going to multiply that once we get it simplified. We've got an odd power. Okay, you try this. You do E. I'll pause. Okay, so we need to split 4w to the 13th into two factors, one of which has a square root, 4 has a square root. The even power, w to the 12th. What are we left with? We've got the 4, we need w to the 13th, so w to the 12th times w. We split out this thing that has a square root, the square root of 4w to the 12th, times the root of w. We take the square root of 4w to the 12th, which is 2w to the 6th, times the root of w. There's a w in front multiplying that. 2w to the 7th root w. Okay, one more. So we've got negative 2y squared. Right? Throw an equal sign in front because you're saying this line is equal to, it's a continuation of what's going on above. Okay, square root of what part of 8? What's the largest perfect square that goes into 8? 4. Does w to the 6th have a square root? Yeah, it's even, right? So think about what does it mean that it has a square root? It means you can divide the number by 2. So if it's odd, you have to split it up, right? W to the 13th has to become w to the 12th times w. Y to the 6th just stays as y. To get an 8, I need a 2. So I got 4 times y to the 6th times 2. And underneath here, 4 times y to the 6th times 2, you can put brackets around that if you want, is 8y to the 6th. So I've got my negative 2y squared still. I've got the square root of 4y to the 6th, and I've got the square root of 2. So I'm just splitting up this square root. Okay, what is the square root of 4y to the 6th? 2y to the 3. Okay, we've got negative 2 times 2, which is negative 4. Y to the power of 5. We add exponents, right? Powers with the same base. We add the exponents. 4y to the 5th. And a root 2. So negative, don't want to lose a negative, 4y to the 5th, root 2. No real way to check this on your calculator, right? You can check that negative 2 times the root of 8 is the same as negative 4 root 2. You can't check the variables. Okay, part C, restrictions on the variable. So what kind of number can you not take the square root of? Negatives. So in the real number system, you cannot take the square root of a negative number. Now, being as you're looking at this sheet, I don't know why it's all hidden. So, therefore, when a radical has a variable, we must state the values for the variable that are valid. So, root x is only valid if the radicand is blank or blank, and we say the restriction. So I'm going to say it's got to be 0 or greater. And we say the restriction on x is that x has to be greater than or equal to 0. You could take the square root of 0. It's just 0. You can take the square root of any number greater than 0. Okay, now maybe it's root 8, which is 2 root 2, but if you take the square root. Whoops. I moved the wrong. Oh, come on. I'm trying to move this. Just move. All right, let's. Okay, the square root of x minus 5 is only valid if the radicand. So the radicand is the expression under the radical sign. So the radicand has to be 0 or greater. And therefore x minus 5 must be 0 or greater. And we say the restriction on x, so we know that x minus 5 has to be greater than or equal to 0. So what can we say about x? Greater than or equal to 5, right? We're going to add 5 to both sides. Okay, so you're going to move a negative 5 to the right side, it becomes positive 5. So basically our restriction is that whatever expression is under the radical sign, that's the radicand. Whatever expression is under the radical sign has to be greater than or equal to 0. The square root of w to the 4th is only valid if the radicand is 0 or greater. And therefore w can either be blank or blank. Let me say there are. Well, so w is either, it's negative or positive, right? But if you're raising it to the 4th power, what are you going to get? If I take a negative and raise it to the 4th power, I get a positive. Okay? So this will always be defined, so there are no restrictions on w. W can either be, I don't know, so let's say negative. I don't know what the either be. Well, it can either be negative or positive. So w to the 4th is always positive. And therefore w belongs to the real numbers, right? You put any real number in there. Why? Well, if it's negative, you're raising it to the 4th power. It's going to become positive, right? And then it'll be something we can take the square root of. So really, that's any even power. The p cubed or any odd power So p cubed is only valid if the radicand is 0 or greater, again. And therefore p must be, well, if you're cubing a negative, what do you get? You get a negative. So p could be 0 or it's got to be positive. Because if p is negative, I'm going to cube it, get a negative, try and take the square root of a negative. We can't do that. Okay, so the restriction on p is that p is greater than or equal to 0. Okay, so what you're just looking at, what's the expression under the radical sign? If it's, an equation, or not, if it's what's the word? If it's an expression, it's like x minus 5, then you say that's got to be greater than or equal to 0. And then we just have to isolate the x. We add 5 to both sides. If it's a power, if it's an even power, then no matter what the value of the thing is, it's always going to be positive. We can take the root. And if it's an odd power, then the variable must be 0 or positive. Okay, state the restrictions. What are the restrictions on 6, 4x to the 4th? X. It's an even power. X belongs to the reals. Very quickly, this running's going to disappear. Negative w. So you think about it, what do I want? I want negative w to be greater than or equal to 0. What happens if I just erase this and start? No, it's still going on. So negative w has to be greater than or equal to 0. So w has to be less than or equal to 0. The way we get rid of a negative sign is we multiply both sides by the negative, but we flip the inequality, right? So I turn negative w into positive. It's gone. See, told you right quick. Okay, so this one, because it's a 4th power, x belongs, so negative w is greater than or equal to 0. To solve that for w, multiply both sides by negative 1. When you multiply an inequality by a negative, you flip the inequality. Basically, this w has to be negative. Because when you take the negative of a negative, what do you get? You get a positive. Okay, so if w is negative or 0, we're good. This one, what do we want? We want y plus 3 to be greater than or equal to 0. So what can we say about y? It's got to be greater than or equal to negative 3, right? You put a negative 3 in there. Negative 3 plus 3 is 0. You have like a really high average on the cube or something? I don't remember it, so okay, whatever. Okay, well, all right. Maybe you want to do something different this time around. Square root of x cubed over x. Okay, we're cubing x, so we know that it can't be negative. But it could be 0. But then we got an x on the bottom, so it can't be 0. So x has to be greater than 0, strictly greater than, right? It can't be 0, because ultimately we're going to divide by x. And you can't divide by 0. It can't be negative, because if you take the square root of a negative, or sorry, if you cube a negative, you get a negative, and you can't do the square root of a negative. Okay. So just remember your restrictions. Whatever's under the radical sign has to be a positive expression. And there, we're done.